In this video, we're going to find the probability of complementary, mutually exclusive, dependent, and independent events. Let's first talk about complementary events. These are two events where when one occurs, the other does not occur, and together their probabilities add up to 1. An example would be flipping a coin. You have 1/2 chance of flipping and getting heads, and 1/2 chance of flipping and getting tails. You cannot flip and get heads and tails in the same flip. And also, when you take 1/2 plus 1/2, you get 1 whole. This brings us to mutually exclusive events. These are two events that cannot occur simultaneously. An example would be rolling a dice. You can't roll a dice and get a 1 and a 6 on the same roll. You'd have to roll it twice to get both of those numbers. Now, the difference between mutually exclusive events and complementary events is that the probability of the mutually exclusive events does not have to add up to equal 1. Now, let's move on and talk about independent probability. Independent probability is a form of compound probability, meaning that more than one event is happening at the same time. With independent probability, the outcome of the first event does not influence the outcome of the second event. The key word on some of the problems is the word replaced. For example, if you're pulling marbles out of a bag and you don't replace it, then the outcome of the first event does influence the second event. So if you don't want it to influence it, you have to replace it. When we have compound probability, you find the ratio of each probabilities and multiply them. Let's go through this example together. It says that you spin the following spinner and roll a fair 6-sided dice. Find the probability of the following. Notice that I have this capital B, and then I have something in parentheses. This is read as the probability of spinning a red and rolling an even number. With compound probability, the key word is the word and. That's telling us that we're going to have two events. So as I said, we're going to find the ratio of spinning a red and multiply it by the ratio of rolling an even number. So look at the spinner. What is the probability of rolling a red? There's 1 red out of 3 total. Then think about the numbers on a 6-sided dice. How many of them are even? 3 out of the 6 are even. So now I can take 1/3 times 3/6. That gets us 3/18. Next, we need to simplify. You could divide a 3 out of both the numerator and the denominator. So our probability is 1/6. If I was going to spin the spinner and then roll a dice, we would expect that 1 out of every 6 times you would get a red and then roll an even number. Now pause the video and try this one on your own. Now let's see how you did. It says that we're flipping a coin. What is the probability of flipping a tails 3 times in a row? That means that we're going to have the probability of flipping a tails times the probability of flipping a tails times the probability of flipping a tails. There's 1 out of 2 sides of our coin. So we have 1 times 1 times 1, which is 1, and 2 times 2 times 2, which is 8. The likelihood of flipping tails 3 times in a row is 1 out of 8. So now let's talk about dependent probability. This is when the outcome of the first event does influence the outcome of the second event, and the key word there is not replaced. Let's go through this first problem together. It says that there are 10 yellow, 6 green, 9 orange, and 5 red cards in a stack of cards turned face down. Once a card is selected, it is not replaced. Find each probability. So we want to find the probability of getting a yellow card and then getting a green card without putting the yellow back. How many yellow cards are there? There are 10 yellow cards. How many total cards are there? There are 30 total cards. Then, when you have probability, you want to assume that you get what you wanted on the first event. So we're going to assume we got a yellow card, meaning there's no longer 10 yellow cards in the deck, there's now 9. Now we can do the second ratio. How many green cards are there? There's 6, but instead of being 30 cards, now there's 29 because we did not replace it. When we multiply, it helps to simplify before we multiply. We can divide a 10 out of both 10 and 30, and then you can divide a 3 out of both 6 and 3. 6 divided by 3 is 2, and 3 divided by 3 is 1. So we have 1 times 2, which is 2, and 1 times 29, which is 29. So the probability of getting a yellow card and then a green card without replacing the yellow card is 2 out of 29.